everyone. I'm going to continue talking about the pioneering works in the domain of team recommendation. And they are mostly focused on subgraph optimization, and I'm going to explain them more. As Hossein explained, at first I want to emphasize again that one of the main goal of this tutorial is to continue the research to gain the properties of the subgraph optimization techniques to help improve the new methods in the machine learning domain and use the strong property of the subgraph optimization and improve the machine learning based methods to recommend the more effective teams. To start with explaining the subgraph optimization method, I want to start with mentioning the consideration of network structure, which is really crucial in recommending an effective team. The network structure can be represented as a social tie, different social ties among the experts, and also can be represented the hierarchical structure between the different organizations. And in this expert network, we can say that the nodes of the graphs can be considered as the experts. The experts are the nodes of this network, and the skills of the experts can be considered as the node attributes, and also the connection between the nodes is the ties, the different ties, different social ties or any other type of ties available and exist among the experts. And so in this case, after forming the network to recommend the team, it is required to find the best subgraph based on the objective which is required for us. And for each required objective, one of the subgraphs should be mined. And so we can say that there is an interdisciplinary relation between the social network analysis and the graph theory. And we can say that the problem of team recommendation can be translated by the graph mining. And if we want to explain it in other way, we can say that suppose that in a network graph, in an expert graph, for example, if the communication cost matters, then after mining, one subgraph, for example, in this figure, the red one can be the answer. And if we change the objective, for example, from the communication cost to the personal cost, then another subgraph can be the answer. So after fixing and considering one objective or some objectives, different subgraphs can be mined, and we are going to find different subgraphs based on the objectives which are important for us. In the literature, different objectives are studied by during the time by different researchers, and we can mention the communication cost, proficiency, personal cost, as you can see, geographical distance, density, and also some works try to optimize some of the objectives simultaneously, and we can name all of them as multi-objectives. If I want to explain some of them, I can start with communication cost, which is one of the important objectives that's studied by most of the works in the literature. Communication cost, is a metric that measures how effectively different members of team can communicate to each other. And we can say that the lower communication cost means that team members can easily communicate to each other and can understand each other better. And there is an assumption, and by this assumption, there is a one-to-one correspondence between the communication cost and the team performance, in a way that by decreasing the communication cost, the performance of a team would be increased. Researchers usually accept this assumption as a true assumption, and then by this assumption try to find the subgraphs, the teams that the communication cost is minimized. That's why communication cost minimization is one of the goals by different researchers during the time. And as the computational point of view, we can say that different formulas have been used to compute the communication cost between any two experts in the network. And here I can mention two of them, which are mostly used by different researchers. And as you can see, in both formula, the communication cost is computed based on the number of the joint works between each two of the experts. And in this table, if we look at the team recommendation works in time, we can see that almost all of the works, all of the researchers try to minimize the communication cost, but in different methods. And if we want to categorize the methods that have been used to minimize the communication cost, we can mention, have to divide it into different categories, non-temporal and the temporal methods. At first, in non-temporal methods, we can say that in these methods mostly use different types of graph-related methods. For example, minimizing the sum of distances, or minimizing the sum of edge weight, minimizing the diameter, or minimizing the spanning tree. For example, in this figure in the left one, you can see that the blue line is the diameter of this graph. So to minimize the communication cost by the method of minimizing the diameter, the subgraph with minimum diameter should be our answer. And another method about the spanning tree, we can see in the right figure, the red dashed edges show the spanning tree of that subgraph. So the subgraph with minimum spanning tree is the answer if we want to choose this method for minimizing the communication cost. And these methods were static. And about the temporal or dynamic methods, the intuition is that the intuition for these methods is that during the time, the communication cost among the different experts may change. That's why a term is added in this method. A term is added to the original formula, and we can see that alpha times t minus t prime, and t is the current time, and t prime is the last time that two experts have a joint work together. So in this way, we can help the formula to give a positive effect for the experts that recently worked together. After communication cost, I want to mention some about the proficiency. In general, we can say that the proficiency of an expert is the level of expertise, maybe in one of the skills or in the whole career. For example, in the research domain in academia, we can say that the H-index or the number of the citations can be a sign of the expertise. And also the proficiency is named by the other names, for example, the authority. And also, in general, we can say that the proficiency is desired to be maximized. A team or a subgraph with maximum proficiency is desired. But to change the maximization problem to a minimization one, sometimes some formulas is used by summation over the 1 over the expertise, and in this way, by this technique, the maximization problem is changed to the minimization one, and in this way, a researcher can minimize some different objectives simultaneously. For example, they can minimize communication costs and also 1 over the expertise together. Okay, if we look at again to this table, we can see that most of the recent works decided to maximize the proficiency in their works. And in general, on top of the simple objective optimization that we mentioned, some of the important ones, many works try to optimize different objectives simultaneously. For example, communication cost and proficiency, or communication cost and personal cost, or any other combinations that are studied during the time by different researchers. And again, by another viewpoint to this table, we can see that most of the works try to target multi-objective optimization. For example, communication cost with proficiency with different methods. These are the different methods and different types of optimization that are studied during the time by the researchers. Okay, after some explaining about the objectives that are studied by the team recommendation works, I can talk a little about the algorithms, subgraph optimization algorithms. In general, as I mentioned, team recommendation is a subgraph mining. And in general, it is proved that subgraph optimization problem is proved that it is an NP hard. Because of this, different heuristics are proposed to solve the problem in the polynomial time, and by different methods, by different greedy and approximation algorithms. And if I want to mention the first work that tried to solve the team recommendation as a subgraph optimization, we can mention the work of Lapas. It was the first attempt, and in this work, the goal was minimizing the communication cost, and the methods that are used in this work has been minimizing the communication cost by the diameter and also by the spanning tree optimization. And the Rayler-Fest was the algorithm that minimized the communication cost by minimizing the diameter. And Hauer-Steiner and Enhancer-Steiner are two algorithms that minimize the communication cost by the spanning tree optimization. Here, I only want to mention one step of the Enhancer-Steiner algorithm. It is a visualized version of this algorithm, only the first part of this. For in a graph, suppose that these are the experts with different skills. At first, the algorithm tried to form and generate an augmented graph in a way that for each of the skills that exist, one skill node is added to the graph, and then that skill node is connected to all the experts that associated with that skill. And then each expert is replaced by a complete subgraph, and the order of complete subgraph is equal to the number of skills that the expert has. For example, this expert has 2 skills, so K2 is replaced. There are 3 skills are associated with this expert, so K3 is replaced, and then all the connections are added. And in this way, after forming this augmented graph, then another version of the previous method algorithm applied to this graph, and by forming these extra edges, the algorithm can find the best team in a more effective way.